Hi guys, this video introduces the concept of container adapters. This is an idea that's used in stacks and queues in the C++ language and in data structures in general. Let's review some terminology first. A container is just a class that implements some data structure that contains elements. For example, standard vector is a vector data structure. We call it a container because it contains numerous elements in it. An adapter is a kind of container that itself uses a pre-existing container to implement a new, different interface. So the idea here is that the adapter provides a higher level API. API is application programming interface. That's the public functions that you're allowed to call. This is higher level. So the data structure details are abstract. Things like nodes in a linked list, indices in an array, resizing, stuff like that is abstract or hidden. The user of the adapter code doesn't have to worry about those details. It's just a simpler API that's easier to use. This is an example of the concept of reuse in software development. The idea of reuse is that it's a good thing to use predefined code to create new code. We don't want to create everything from scratch every single time. The whole point of these data structure classes, for example, is that you can use these in practical software instead of having to worry about how to manage data structures yourself. You shouldn't have to write your own data structures. You can use these. This is similar to the idea of reduction that exists in more theoretical settings. Reduction is the idea of using a predefined algorithm or data structure design to create a new algorithm or data structure. It's really two ways of talking about the same thing. It's just reuse is talking about code, and reduction is talking about the concepts of algorithms and data structures being used in new ways. This is a key skill. This is how technology gets created. All of the new software innovations that we're used to are created this way, where there's an old existing API and people reuse it to do something totally different. You know, when the first MP3 player was created, there was no MP3 player software. People used existing libraries that weren't meant for that to make MP3s a thing. In order to make one of these reuse or reduction adapters work, you have to work out the correspondence between the operations that you're trying to implement, the new ones, and the operations that you already have in the code or data structure that you're reusing. Remember, an adapter is a container that uses a pre-existing container to implement a new different interface. So there's two interfaces going on. There's the old pre-existing one that has already been created, and then there's the new one that you're trying to implement. We're going to call this a correspondence. A correspondence is that each new operation corresponds to operations in the pre-existing structure. So every new concept in this new structure or API that you're creating corresponds to some concept in the existing code or the container in our case. This is a problem-solving challenge in creating a container adapter, or really any of the kind of reuse that I talked about earlier. The code that you write follows directly from these correspondences. So you really need to work out mentally the design of the correspondence of new operations to old operations before you sit down and try to write code. Usually once you do that, it's pretty easy to write the code. I'm going to go through a case study here to show the idea of an adapter before we move on to data structures, which are a little bit more complicated. So let's say I want to implement a class to store a three-dimensional point. Over here is a figure of a cloud of three-dimensional points. These are XYZ coordinates in space, and they correspond to this picture of a bunny rabbit. I've got the credit for the image there. So let's say I want to implement this. I want to write code that can store a point cloud that's a set of many of these three-dimensional points, thousands or millions of them, and each individual point needs a data structure. We're going to call this a point 3D for a three-dimensional point. I would probably rather call it 3D point, but you can't start an identifier with a number in most programming languages, so it's point 3D to get around that rule. There's a few ways of implementing this, but to illustrate the idea of a container adapter, I'm going to show how you could create a container adapter to implement a three-dimensional point. So first, let's look at the new operations. This is the new API we're trying to implement using technology we already have. There's a x accessor and a set x operation to mutate the x coordinate, and the same thing for y I can get in set y, and the same thing for z I can get in set z. So those are the 6 operations that are new that I need to implement. And I'm going to use the predefined data structure of a vector to implement these. Again, there's other ways of doing it, but that's how we're doing it right now as an example. So in order to design my point 3D class, this is the new adapter, I need to work out the correspondence between the 6 operations that I need to create, x set x, y set y, z set z, and the vector operations that are already defined. Vector has operations like get the size, set an element by index, get an element by index, resize, stuff like that. So here's how we're going to do it. I'm going to say that the x coordinate, the new concept, corresponds to the vector element at index 0. And y is going to correspond to vector element 1. Z is going to correspond to vector element 2. So in order to set x, that corresponds to setting vector element 0 to a value. And the same goes for y and z. The important idea here is we're showing how to connect or correspond the new operations with the old ones, the ones that are already available to us. Here's what the code would end up looking like. It's pretty straightforward. So I've got my class point3d. I have a standard vector of double called chords. That's the data structure that's doing the actual work of storing the XYZ coordinates. So once I have this vector, vectors are powerful things. We've gone through all their capabilities. It's pretty easy to make this class. I have a constructor that creates a vector with 3 copies of 0, so it's initialized to the origin by default. My accessor just returns coordinates at index 0 for x, and same thing for y and z at indices 1 and 2. And to write set x, set y, and set z, I just assign chords index 0, 1, and 2. And that's it. So the point of this is once we have these powerful data structures defined, these containers, we can use them to then implement higher level data types. A vector is just a generic collection of elements. Now I'm creating something that is useful in our business application of a 3D cloud point. Okay, so next what we're going to see is how to do this adapter idea to implement stacks and then later queues.